Hey guys. All right, so we are going to be going over one sample t-tests for Lab 4. I do want to let you know that the regrading is coming slowly but surely. I've just had my fair share of things going on over the last couple of weeks, including my classes and some like personal family stuff. So my apologies in advance, and thank you guys so much for your patience. So for today's lab, um, I'm going to be going over two of the questions out of the four questions, I believe, in the lab document. Two of them, the first two are the same, and the second two are essentially similar. So, calculating one of the first set of the two by hand so that you can do the other one by yourself. And then out of the second set, one of them using R again, so you can do the fourth question by yourself in lab. Okay, so first, like I said, we're going to use hand calculations for a one sample t-test. But first, remember, uh, I don't want to get you guys too confused because we just did the one sample z-test, but with the one sample z-test, we have the population mean and the standard deviation given to us. So both of those things are known, and we're using the one sample z-test to compare that single sample mean that we don't know to the known population mean. So with a one sampled z-test, we're looking for the standard deviation of the population. So now we're going to be using a sample t-test, one sample t-test. We have the standard deviation, or we do not have the standard deviation of the population, excuse me. And we're trying to compare that single sample mean to the known population mean, which is mu. So we have to figure out the standard deviation of that sample in order to estimate the standard error. So in short, just look for the standard deviation of the population. And this will all make sense once we're going through the five steps, although I'm sure you guys have it down from Dr. Liu's lecture today. Starting off with question 2. So we have, I'll just read the question quick. A researcher hypothesizes that people who listen to music via headphones have greater hearing loss and will thus have a lower score on the hearing test. That's bolded for a reason, you'll see in a minute, compared to those in the general population. On a standard hearing test, the overall mean is 22.5. And the researcher gives the same test to 12 individuals, so that's our sample, who regularly use headphones. Their scores on the test have a mean of 18.83 and a standard deviation of 3.79. So we're going to use the 5 steps of hypothesis testing for a one sample t-test, and our alpha is going to be at 0.05. So the 5 steps are here. The first thing we need to determine is the null hypothesis. So we're saying for the null hypothesis that the population mean is greater than or equal to the overall mean on the hearing test, which is 22.5. And then we have the alternative hypothesis, which is saying that mu is less than 22.5. And it's less than because if you go back to the passage, they're talking about hearing loss. So inevitably that'll lead to a decrease in a score on the hearing test. So that's why it's going to be um, less than 22.5 as opposed to greater than. For step 2, we have to state the decision criteria. So we have our alpha, and then which is 0.05. Our degrees of freedom is the sample size, which is 12 minus 1. So we get 11. And then t crit, the critical value for t, we can find via the table. So remember, this is directional via the alternative hypothesis that we've given. So we're looking for the proportion in one tail. So 0.05 is our alpha. And we have our degrees of freedom as well, 11. meaning our critical value for t is going to be 1.796. However, remember, we're guessing on the left side of the distribution, so negative. So that critical value is going to be negative as well, similar to the one sample z-test that you were doing. And then step 3, we're going to compute the sample statistics. We have the sample mean, which is 18.83. And then we also have the standard deviation of that sample, which is 3.79. And we also know how many people are in this sample. So we have all the information that we need to calculate the standard error. So 3.79, the sample standard deviation, divided by a value that you can't see here. I don't know why it's over here now. The square root of the sample size, which is 12, and then you'll get 1.09 for the estimated standard error. And now we're going to compute our t observed statistic. So 18.83 is the sample mean, and then 22.5 is the population mean. So we subtract these two, and then we divide by the standard error that we just got in step 3. And so our observed statistic, t statistic, is going to be negative 3.36. And now we have to make a decision. Because t observed, so negative 3.36, is less than the critical value we found on the table, negative 1.796, we can reject the null hypothesis. So people who listen to music via headphones tend to score lower than the general population. And again, I encourage you guys to draw these distributions out. It really, really helps for conceptualizing this information. And then you'll see also that this answer right here that we gave is written in APA format. So going forward, just make sure to include your answers in APA format. It'll make it easier for you in the long run. And now we're going to be using R to do the same exact calculation. And I should say for question 1, because I believe that was question 2, question 1 is essentially going to be the same exact thing. Just make sure you guys are paying attention to the direction that the hypothesis is positing. Okay, this is our second example. So now we're going to use R to calculate a one sample t-test. And I'll just go ahead and read it again. Why not? So personnel department for a major corporation in the Northeast reported that the average number of absences during the month of January and February last year was 7.4. So that's the population population mean. In an attempt to reduce absences, the company offered free flu shots to all employees this year for a sample of 10 people. So our N is 10 who took the flu shots. The number of absences this year were that set of numbers. And then the question is asking us, do these data indicate a significant reduction in the number of absences? So obviously that language is going to tell you something about the direction of the relationship that we're looking into. And then our alpha is going to be 0.05. And I guess if I remember, hopefully I remember to say this at the end of the video as well, but just make sure you guys attach your output onto your lab worksheet somehow, whether you're like attaching it in addition to the worksheet and uploading all of that stuff to Blackboard, or just literally screenshot and copy and paste your syntax and your output onto the lab document. And obviously make sure to indicate your observed value for t. So again, the steps are going to be pretty similar here. Step 1, it's going to be a one-tailed test because the question is asking us about reduction. So similar to question 2 that we did before, we know it's going to be a one-tailed test. So we have our null hypothesis, which is saying mu is greater than or equal to 7.4, and then the alternative hypothesis that we're trying to prove is mu is less than 7.4. We have our decision criteria as well. We know that the alpha is 0.05. We know what our sample size is, which is 10, and then -1 is 9. So this is degrees of freedom. And that'll help us for getting that critical value of t, which is 1.833. And then remember, it's asking about a reduction, so that value should be negative as well. So now we are going to be computing all of this stuff in R. Whoops. So it's pretty straightforward here. The first thing we're going to do is enter in the data set. So you can just literally copy and paste that data set. First, I can type it out as well. So I'm assigning the value x, and then the C is count, and then you can literally just copy and paste, like, as opposed to typing them in one by one in case you mistake it. So there's that. And now that we have our data set assigned to a value, which is x, we're going to run a one-tailed t-test. So this is the syntax for a t-test. You do t-test, and then left parens, the right one will pop up, obviously. So x is this value right here that we've created. And then mu, which is the population mean, is 7.4. And we are using a one-tailed t-test. So the alternative hypothesis is saying that is less. So it's on the left side of the distribution. And now we can run it. So we can see down here, we have our observed value. We have the degrees of freedom. We have the p-value for the sample. And we have the sample mean as well. So now that we have this output, we have pretty much everything we need to make a decision. I'll have them side by side here just so it's a little bit easier. Just of note, I should mention this. We are doing, again, a one-tailed t-test, excuse me, meaning that our alternative hypothesis is saying that it's going, like, we're looking at one direction, basically. We're not asking if there's a difference. We're saying, is there going to be a reduction? So we have to input this value here. If it was a two-tailed t-test, then you don't really have to write anything. You could just end it right here with the parentheses, the right parens, and then just run it without this stuff, basically. But again, we're doing one-tailed t-test, so we have to specify the direction. So left side is less, and then right side is greater. We have, again, our sample mean right here, 5.7, which we got from down here. And then now we can compute our t-statistic, or we did compute our t-statistic, excuse me. So t observed is going to be negative 2.61. Go to the hundredths place. We don't need to round up. And then our significant, our p-value is right over here, 0.01407. So I would go to the thousandths place over here. It just tells .014, I guess, says a little bit more than .01, but you can also just enter in .01407 just to be safe. And now we can make a decision. So we can make a decision in two different ways here. We can either compare the observed value of t that we just calculated, so negative 2.6128, and then compare that to our critical value for t, or we can compare our p-value here to our alpha of 0.05, and just using this p-value here, the p that we got is less than, oh, I can't highlight anything, is less than 0.05, so we can reject the null hypothesis. And instead of, like, usually I think you guys are more used to just writing this out. As we go forward, we're going to be doing things more and more in APA format. So this is a really good way to kind of get that system down. It's very much like APA format is just essentially a template. So like this is really going to be the same template that you use, I guess, until you don't have to use this until you have to add more information. But by template, I mean like there's the type of analysis that we did, and then we're saying what the hypothesis was. So whether there was a significant reduction in the number of absences, we gave the population mean as well among people who took flu shots. And now we're giving our descriptive statistics here that we got. So make sure to include the mean and the standard deviation, because the mean alone is not going to tell us anything. We need that standard deviation there to understand the sample a little bit better. And then also write your answer out here. So T is italicized, and then we have the degrees of freedom, which is 9, equals our observed value, which we got from here, negative 2.61, and then p is less than 0.05. So, and p is also italicized. So look at these red spots here, italics, and then we've got spaces here. This is literally the format that you guys should be using for t-tests going forward when you're asked to put it in APA format. And then we say what this means basically right over here. So it indicated that there was a significant reduction in the number of absences after they received flu shots. So that's pretty much it. I guess I'll see you guys in lab. But yeah, the other question, question 4, is going to be similar to this. So you have a foundation to work off of using this video. And then question 1, I believe, as far as the hand calculations go, will be similar to this question. So now you have a foundation for that as well. And that's all I got. Thanks, guys. See you soon. Bye.